Ah, appears that we're live. We'll do the usual make sureing thing. So, just to be careful.
Ah, appears that
Yes, seems to work. All right. So no huge agenda, just a little conversation maybe about gravity and just some of the things that are sort of evidence, um, contributing evidence, extra evidence that maybe they just should have rethought this a little bit, and realized that, you know, you can sort of deduce that they really just don't have the right answer when it comes to gravity as just being some kind of magical thing, that we don't have to bother explaining it. I think we want to use this instead. Don't know if this will work when I click on this. Yeah, well, don't need the chat really. At least this part seems to be working. All right. So just for clarification, I am proposing that all the forces, because they all move the same speed, are all the same thing, and they're just slight variations on a theme. So gravity would be just a bunch of junk, little bits, quanta, and they're all the same, unlike what I'm drawing here, in the sense that they're all the same size, and they're just the only thing that's different is they come in these two varieties. So you could say black and red, or you can use any kind of qualifier for the fact that the little bits are mixed, and they move the speed of light, and they move in all directions, and that's out there in space all the time. And so what we can detect, because of how they affect electrons, um, well, we obviously detect gravity. So, but I'll get to that. Obviously. But when they are at a specific frequency, that is a specific distance apart from each other, like bullets, um, we detect them. So we could say that was blue light, and then red light would be almost twice as far apart. And so when they come at a specific period between between their existences in a pattern, we detect that as electromagnetic spectrum. Call it radio or different kinds of radiation, but that's what it is. And it's of one color. It's not. It's it's basically the electron force. So there's two types of force: electron force and proton force, to correspond to the two types of matter, which are essentially the electron and proton, which is positive charge, negative charge, which is positive monopole, magnetic monopole, negative magnetic monopole, however you want to describe it. So a magnetism, is a phenomenon created when this force, which comes in this mixed colors, I guess I could draw that in some sense. Probably shouldn't have used this program for this. Yeah, probably shouldn't have, but I did. So, oops, see, and it changed the color on me. I don't remember it does that. So when I change the color, the last thing I drew, it changes the color on that too. So it's just making this more difficult. This should be red. I want red, please. Red, thank you. Oh, now it's red. Well, whatever. All right, comes in mixed, and then when it goes into a magnet, I guess we'll just draw a magnet. Really bad magnet, as I'm apt to do. And then I'll have to click, and then I can hit black, I think. Oh, no, I can't. Strange. So I have to draw this, and then hit red, I suppose. Okay, sort of worked. So a magnet is basically a bunch of these little polarized things. So inside the magnet, you have to imagine a bunch of little magnets. being the atoms. But the point is the overall effect magnifies that effect. And the bottom line is that this becomes a filter, which means the force comes out filtered. The red bits are separated from the black bits. I have to draw one here, I think, and now I can switch the color. Yes. And everything's a learning curve. I just like this because it did the little slanty line thing, which is kind of nice, but this is, well, anyway, it's not the right program for this. Anyway, so you can get the idea that that's what a magnet's doing, is separating, filtering, and now the force, in effect, by simple rules, where the black force will reflect off of black. So when black force hits a black thing, okay, it reflects. When when red force hits a black thing, it leaves perpendicularly. In this case, perpendicular would be outside the red end of the magnet. And when black force hits the red end, it comes out the black end. So it leaves perpendicularly. And when it hits the red, when red hits red, it reflects. So you can understand that when two magnets have their poles facing each other, there would be an awful lot of reflections going on. And those reflections are an expression of energy. So the closer you bring the magnets, the more reflecting and the more impacts and the more energy, which means the stronger the repulsion gets. And the inverse will be true. If you turn the magnets around, the filter will work exactly the opposite. All the reflective energy will dissipate, be converted into perpendicular motion inside the filter, and you will have no pressure between the opposite poles. All the red energy will go out the black, all the black energy will go out the red, and you'll have nothing in terms of energy between the magnets. No energy between the magnets, then the energy outside the magnets pushes them together. So just pointing out that, so you start with one force, okay, one force, and you can see it has these different little manifestations. Two would be the photo, the visual light, everything we call like a photon, which is just this force at a frequency. And then you have these magnetic effect, all of these things moving at the speed of light, as proven by Maxwell, at least in the case of magnetism and the electromagnetic spectrum. But clearly it's also been demonstrated by many circumstantial proofs that gravity also moves at the same speed. So it's just one force, two specific manifestations, which is, this is the, EM spectrum, you could say, and which is sort of a misnomer altogether because it really has nothing to do with electromagnetic. This is magnetism. Okay, so this is legitimately called M. Okay, the filtering effect, and all one force. So gravity. Let's see, is there any way to clear this whole screen? I don't even know if there is. Is it a selection tool? Shit, I should have thought of this beforehand. See, select all. Do I have a select all here? I do. So I should be able to delete all. So you saw all that stuff, right? So if I delete it, you saw it all. Gravity mixed, photons at a frequency, magnetism filtered. All right. So let's see if there's any comments just for that. All right. Typical, sadly. All right. So we have a pile of matter. And presume spherical symmetry eventually anyway. And the idea is that we see quite obviously that there's this pressure that takes place where each individual little atom in the earth or whatever the body is moving towards what appears to be the center. Now, it's sort of only an appearance of the center, but anyway, it all appears to be heading that way, compelled to accelerate towards the center of mass. But what we also observe is that if you put a lump on this body, mountain, you will realize a more gravitational effect, is you will create a longer radius, but more importantly, or more obviously perhaps, you'll create a longer diameter. Okay, the hole thickness will be thicker and sort of important. But anyway, so first off, just this idea that all these little bits are being pushed. And we see the consequence of that is that each little bit inside the Earth is still accelerating. And each bit of acceleration is a real bit of what you could call weight or impact. It's all banging into the stuff below it. So the more crap you have above your head, so to speak, if you're inside the Earth, a lot of pressure, a lot of weight above you. It's all still moving towards you. It's all accelerating down on you. So the pressure is very high down here, high pressure, very high, in the center. Not because necessarily because there's any kind of gravity in the center, just because there's a lot of these little things that are being moved by gravity. So that's one reason to sort of say, well, maybe this gravity thing doesn't have anything to do with any kind of bent geometry, because it seems clear that it's affecting these little bits. And I would argue that it's a nuclear force in the sense that it's really just affecting the protons and the electrons and accelerating them. And they're accounting for this effect, which is the effect being that for the atoms to move, they have to essentially absorb energy. So this force, these little bits I was talking about before that make up photons and, electrons and, photons and magnetism and gravity. So they're just little tiny things moving the speed of light. Now I should distinguish them with some sort of, so the difference. I should make them I should make it more obvious in some way, but I don't know exactly how to do that, so I won't bother. And again, you have to remember there are these two colors, for gravity, of these little bits moving the speed of light. And, that stuff is hitting the little atoms. When it hits the atom, so let's just draw a little atom. And when it hits the atom, essentially the momentum gets stuck in the atom. So I've sort of explained this, that you could sort of understand it as a U-turn, and it just gets stuck in there. So something goes in, all right, but nothing comes out. See, nothing's over here. Nothing came out. This went in, got stuck in here, didn't come out. And this whole thing moves at a much slower velocity, but at a velocity as a result of capturing this. So by capturing one of these little bits moving the speed of light, you essentially capture whatever its direction was. So whatever its vector of momentum was, you've consumed that vector of momentum, and the atom now moves. Now, when you consumed it, like I said, it's obvious it was heading for somewhere, and now it's not going to get there, quite obviously, right? You're just, hey, it's not there anymore. And that's the nature of gravity, is you're absorbing when all these little bits are going through the Earth. And so you got a lot of little bits here that are pressurizing, and they're moving towards the center. and they're going both ways, but they understand we're counting this radius when that's why I pointed out the diameter, when it's really this radius that's doing the work, the opposite side. So this side is absorbing a bunch of this directionality, motion, that away. It's absorbing the motion. So the motion doesn't get up here, and all these little force bits, all the force doesn't get here. And so somebody standing here, a little loud. Well, that isn't even close to. Yeah, it doesn't even, not even close. But anyway, little star human. So somebody standing here isn't going to get hit by all this force that would have hit them. So there's the forces moving the speed of light. It was all absorbed, got eaten by these atoms. That's why the atoms are moving. That's why they're creating pressure. And I'll explain further why they're creating heat. But all of this absorbed energy isn't getting to this object. So there's low pressure underneath him because there's less pressure. So the outside world has even pressure. There's even pressure coming from this direction as there is this direction, presumably in the universe. And so some of the stuff going this way, so to speak, has been absorbed. Therefore, this pressure is stronger by default. So the low pressure is basically what you're moving into. And although there's a whole bunch of stuff being absorbed going down this way, you're part of a pressure that's absorbing pressure going this way. Well, yeah, that's not going to affect you any. That's going to affect somebody else. Okay, that's going to affect somebody standing on this side of the earth, but it's not going to affect you. So in a sense, the people in Fuji are creating some of the gravity that's keeping you pushed down. They're absorbing energy, okay, pushing them down. And that energy they're absorbing is creating the low pressure below you that's pushing you down, and vice versa. So in a sense, we're consuming, kinetically using, actively participating in the absorption of energy that is causing an energetic effect in an equal and opposite manner. So it's like one person is essentially creating the gravity for another person. So if you could theoretically just make a piece of glass or something, and if humans had, if you could go into a perfectly weightless environment or an environment that had absolutely no other gravitational effects, no doubt you could, if we could stand still enough, we could hold each other to the ground with our gravity, to this piece of just anything, any surface you put in space. And the effect is magnified. The thicker you make the surface, obviously, then the surface helps absorb the energy. It just gives us more mass, so to speak. So the more mass we put below us, if each one of us stands on a 10-ton weight, then it'll work even better. And if each one of us stands on a 5 million ton weight, then it works even better. It just gets better and better the more mass we include as part of ourselves. But it's so it seems so obvious that this is there's a real thing happening. There's real energy. There's real stuff moving towards the center of the earth. And it should have occurred, I think, to physicists to just say, well, what's the consequence of that motion? Doesn't the Newtonian equal but opposite thing sort of imply that there would be an equal and opposite reaction, and that this is just a mechanical consequence of this acceleration? And the acceleration, as we understand all other accelerations, this battery doesn't accelerate unless I do something, force it to accelerate. And it's just kind of ironic that the most obvious force, the most obvious acceleration that we see in the world, the most common, the most everyday acceleration we see, and we've attached to it no notion of an actual force that's making it accelerate, the absorption of a force. Where in every other circumstance, we understand that we have to push force into something. We have to do the equal and opposite reaction. We have to watch the big flame come out. We have to watch the pressure. We have to watch we have to do the energy thing. And the energy thing always has that, if you want to go this way, you have to make something go that way. I mean, that's just a fact of physics. You want to do something, you want something to go this way, you have to make something go that way. I mean, damn, not that complicated. And it's just a huge intuitional piece of evidence defending an idea of a real force being responsible for gravity, not some sort of bent imaginary substance, imaginary force. Where was I? Was I there? I was there. So we can pop the chat on, see if anything's happening. What? Thanks. Okay. Yes, I unblocked you. Yes, it's true. So yes, anybody who wants to get unblocked, just email. Should be below the email address, ds@draftphysics.com. Or some other email address that might work. For which there are numerous ones, but anyway, it doesn't matter. Let's see, how else do I want to, this I'll go to the program where I can draw the arrows. Yeah, arrows. Yeah, I really like arrows. I don't think this is probably just, this is the only part that stays open for whatever reason. Doesn't really matter. Line, I think. Arrow, right. Okay, and then I have to, stupid color selector, so annoying. Got to figure out how to fix this so I can switch colors easily. So the interesting part is inside the Earth. I need a regular line for this part, a brush or something. All right, so you have an Earth. Oh man, holy smoly! Well, I just make it many lines and then it'll look more roundy. Whoa! Hey, it's I'm kind of liking it all of a sudden. Ooh, yeah. Anyway, all right. So you have something roundish. Presume that is something roundish, and so we're back to this force crap stuff. I mean, oh, I hate this thing. And then we'll go to arrows. All right. So you have this idea that there's all this stuff moving. So this crust of the Earth, whatever, it's all moving towards the center of the Earth. But it's really moving. Okay, so let's get this right, because of what's absorbed going this way. So this line, okay, the stuff that absorbed acceleration this way is what's creating the gravity or the low pressure that's causing stuff to move, to accelerate in this direction. So, just understand, it has nothing to do with the center. The center is arbitrary. It has to do with the fact that these 2 points, the arbitrary center creates two dimensions. It creates the equal but opposite reaction. It creates the possibility to draw these 2 arrows intersecting, which sort of defines, why there's gravity. So it's, again, it's the acceleration this way that creates the acceleration this way. They create each other. they cause each other. All right, so the atoms inside the Earth, though, are okay. So now we'll try to figure out a way to illustrate atoms. All right, we know the atoms are made out of these little bits, the electrons on the outside, and we'll do them red for the this just happened to work out that way. Yeah, not necessarily maybe we'll use blue for the protons, just to keep you on your toes. And so you have these protons in the middle, and part of the game to understand is the protons are a little more massive than the electrons. So even though their charge is the same, their density is greater. So that at a distance, like out here, this thing feels positive in the sense that you'll feel the proton pressure. So an electron wants to move towards the atom from out here. But as soon as the electron gets closer, and it gets near this other electron, then the repulsive forces kick in and it becomes negative. So I don't know what color to use for this. What the hell? What do I care? I should just use some other color to get the signs right. So there's a range where the strength of the electron is weak at this distance because there's more of this blue crap. So out here, it feels inviting to an electron. But in here, when you get close, then the electron kicks in as being stronger because you're closer to it. So even though its force has got less range, so I guess the way I should have drawn that was the range of the nucleus goes out here, this greater distance. And the range of so I guess I draw another arrow or two just to get this idea that it's a longer distance. And the range of the electron is much shorter. So, but once you get close, then the electron becomes the dominant force, the more sensed. And so it becomes repulsive. So that's the problem with pressure, is that the atoms are essentially have to function in that circumstance. Let's see if I can get rid of this whole blob. I didn't select anything. I thought it would be a selection thing, but it wasn't. Well, let's try making a big square, yellow square. All right, then I can draw some other color on there. That'll do. I'll assume it'll do. All right, so hopefully I can. Yeah, it's still got these little things on it. Strange. Oh, now it doesn't. You always have to keep changing the damn drawing tools and everything too. So many things to keep track of. Wait, just an awful lot. So anyway, so the trick is that this pressure thing, atoms really do. Some of them they do. They want to. All right, so let's draw another version of the atom, and this time we'll just kind of draw. It's all in one color just because it's going to be easier to do. So here's your nucleus. We'll draw that as a square. So that's your protons. These are your electrons. So when you have so if you have a circumstance where the electrons are not, there's a gap. There's a place where there's no electron, so to speak. Well, then obviously there wouldn't be this pressure problem when the electron gets closer. And that's sort of the nature of combining two compounds, is that you have an atom that is minus an ion, it's minus an electron, and another atom shows up, that isn't minus. It's got exactly what it's supposed to have. And you can just sort of see that, well, this can just be moved over here and they'll all fit together and it'll be a nice two complete atoms, even though technically they're short an electron now, technically, because they're sharing this one. So you can't really split them apart because, the they'll be short an electron. They won't be stable. They'll end up being ions again. But anyway, so the idea is pressure is good for finding to force atoms into these arrangements. So if there is any gaps, where you can have a shared electron, heat and pressure makes it kind of a good thing to be able to force those things together. The bad news is, though, is that there is this repulsive force, okay, that's between the electrons. So this force reflecting back and forth between the electrons, right? There's a force bouncing back and forth, makes it a little difficult for atoms to get close enough to each other. So this is where you get these arguments about you need a certain amount of velocity, okay, for the atom to have to get close enough to the atom to actually make this bond, because it doesn't want to. There's all these elements that are creating repulsive pressure between the atoms. So as much as there's attraction between, say, this proton here and this electron, there's attraction, not reflection, but attraction. I should draw on that red then. Oh, that's not red. Yeah, I don't want to get into too much chemistry. It's just obviously going to get complicated if I do that. Is that red now? No, it didn't switch the color. Bastard. I go to the Trelleborg to hit the right color and it doesn't switch it. It's a terrible pink color. Yeah, I don't like pink. I'll take what I can get. All right, so now that should be red. A bunch of red here. So obviously there's an attraction between this electron and this proton. And there's an attraction between this proton and these electrons. And then you have this problem of the reflecting energy between the electrons and reflecting energy between the protons. Now, the reflecting energy between the protons, because the protons are more dense, is going to be strong at a distance. Okay. And that's also going to have to be overcome when you're trying to push atoms together. But like I said, you also have the closer these electrons get to the other proton, the stronger that attraction becomes too. So you have all these balancing tensions, and it requires a certain amount of energy to force certain atoms together, and blah blah blah, create heavier elements and all this kind of stuff. So pressure. I'm just trying to get to the point that the pressure does two things. It creates heat because there's a bunch of stuff getting pushed closer together, which means the electrons of different atoms are in there closer together. And that's sort of an expression of heat, is the higher pressure. And when that stuff escapes, when the stuff caught between, oh God, I'm just drawing stuff, but where's this, like a circle tool? Give me a circle tool. Square thing should allow me to make circles, right? Square, no. I think it would make circles too. Oh, that's circle. It's a freaking ugly tool for a circle tool. All right, so what am I making a circle for? Remember why I'm making a circle? I don't remember. I know there was a good reason. I just don't remember what it was. What the hell was the reason? But it has something to do with more than one circle. Anyway, so let's say you have a force between them, and the idea would be, just move it over, click on it, select it. So you have these little force bits, and they'd be the same color as the force. Obviously, it's the circle, but I'm just doing this for the sake of clarity. Well, unclarity, really. Well, anyway, the idea would be is that this stuff vibrating between here, the more of this stuff is jiggling because of the pressure, the more energy that's accelerating these different bits. They're absorbing it, gaining accelerations in different directions, and this stuff escapes. And so as the heat starts to escape, that means these things can get closer together. So as they get closer, they can let this stuff loose and create less pressure. And that's apparently most atoms produce a consistent, there's one consistent wavelength of light, infrared, that's highly associated with the bonding pressure. So whatever the pressure is that it takes to push two things together, infrared is right on that bonding level, because a lot of this infrared radiation is created when you force atoms close together, when you pressurize them. Yeah. So what else to say? So it just seems clear that the Earth is molten inside, hot, because of gravity, and that's basically stored pressure. That's a bunch of acceleration that's taken place. So it's a bunch of motion of force that's been trapped in those little traps, little circular traps inside of these atoms, which essentially are the force has been trapped between the electrons. And but it has an original vector of momentum, and the atom is moving with that momentum that it absorbed. And yeah, and so until it releases it, it isn't free. It isn't going where it would have gone, and where it would have gone is now going to feel the low pressure. And it just seems such an obvious, brilliant explanation of gravity. And I just don't see where there's any excuse for saying it can't be that way when that way fits so well. All right, so there, I think I've done what I wanted to do pretty much. Fairly poor illustrations, I will concede. So there really isn't much else. So if the chatters don't have anything, this might be the shortest room yet. Because that's the only real agenda I had. Let's see if I can see if there's any. But there's no comments. I mean, I'm really not getting any useful feedback, so this is really quite discouraging. Hey Gary, I love you, dude. I mean, it's not very helpful. So yes, no comments, and this just hasn't been any new videos of any interest. Nope. So there's just not much to talk about. So, like I said, if you don't have anything, I will go about my business. I mean, I'll go do something else, like sleep or whatever. 10 viewers. Yeah, well. Not brilliant, but it's about average, really. Well, below average, but whatever. So I'll give you a couple of minutes if you have anything. But yeah, clearly not enough participation by the world. So very hard to get people to talk about physics, fundamental principles, the axioms of physics, the assumptions of physics, and how they might be, catastrophically poorly composed. I have a compass which spins around in a constant circle. Well, whatever. I'm sure. Okay. I have a magic wand. Magical, my wand. Whatever. Sure you do. I'm sure you. Why don't you take a video of your constantly spinning compass needle? I'm sure everybody will want to see it. I guess I blocked you for a good reason. I mean, you're just kind of verifying it, aren't you? I mean, somebody posted a comment after me that wasn't a comment, and he posted a link to like a 3-hour, Christian Science flat Earth video. So apparently flat earthers and the Christians are working together now, because apparently the flat earth sort of proves God did everything, because you can't explain how granite formed, because, you know, I mean, what? Okay, so I'm just saying you can't take a video. You don't know what a video. You don't have like an iPhone that can take video. And I mean, uploading a video is so easy nowadays. I mean, it's almost built into the phone. I mean, the phone probably even says to you, "Do you want to upload it to YouTube?" Probably even ask you if that's what you want to do. I mean, I'm just saying it's just so easy to do that anybody who wants to know how to do it can figure it out. I have to study for the explanation. I don't know what that even means either. There's no explanation. You're insane. I'm sorry. I mean, if you actually believe that you're watching your compass needle constantly spin in a circle, your brain isn't working. You're not seeing things right. You're seeing imaginary objects. It's not happening in reality. Okay, your brain is creating this delusion. It doesn't exist as a reality. There's no place to study for an explanation. Except a psychology book. So anyway, I did delete the guy's flat Earth video. I mean, I sat there and wasted 10 minutes watching it, which was really a waste of time. But it's just the typical truther propaganda. They got some old clips from some guy 40 years ago, claiming there's too many rings of radioactivity halos in granite, and it can't possibly have been created a million years ago. So it's just, it froze too quickly. Granite can't freeze quickly. Some kind of, this is, yeah, sure. Okay. God did it. God created big blobs of granite in the earth that look just like they were part of a volcanic bubble. It looked just like the volcano in Hawaii, where all the lava spewed out, and now it's, the pimple is empty, and so it's stopped. For now, the pressure is relieved. I mean, it's just obvious what takes place. We know the physics, so why pretend some idiotic God put big hunks of granite that look just like they were created in a volcano in the ground, just to fuck with our heads? I don't know. People are just so bad. So bad. So the other video I did watch, this fractal woman, she's arguing with Ken Wheeler a little bit about the stupid. I mean, they're both wrong. So there's no point in. She says like Steinmetz is right, but yeah, I mean he's right because it's a different subject and all that crap, and that's correct. But they're still stuck with all this motion around a magnetism that can't possibly exist. We'd notice it. You'd be able to detect it. Just like your spinning compass. We'd be able to verify the existence of the phenomenon. It's an antique that was broken, and in the repair, stopped working properly. That's a great sentence. It's an antique that was broken, and in the repair, stopped working properly. I guess that's it stopped working properly. Does that make any sense? You took your constantly spinning compass to the compass doctor because you said, look, the compass is spinning constantly. And so he stopped it from spinning constantly, and now you're saying it's broken because it works properly. Oh man, people are just insane. All right, Dick Woodman. I'm sure this will be just trash. They said that they'll be able to detect neutrinos in a tub of water tens of feet down in the ground by detecting a flicker of light. What the fuck? Yes, well, they'll be able to detect, the random bits of energy the universe produces. So clearly, the universe can produce phantom photons. It can create lots of things. I mean, the photodetectors. Is that the word they use for the ones that work on electrons, right? Photodetector. Where they call them something else, but they have to They have to cool them, to first isolate them from random bits of energy. And the truth is you can never eliminate the fact that there are actual random photons. There is some random photon noise. That's why we don't, probably that's one of the reasons why we don't see smaller bits of light, is because when you start seeing smaller bits of light, you have more noise in your view. And noise isn't very useful, obviously. But yeah, the whole neutrino thing is just, yeah, well, a neutrino can go through 600 light years of lead. Okay, so they're arguing that a neutrino could travel through 600 light years thickness of lead. So lead so thick that it's as thick as a galaxy, and the neutrino would go through that. And yet they think they're going to detect one, just by going a few feet underground. No, that's silly. And how are you going to detect something? The other part that's just silly is that they don't really have a rational explanation for how this billion times lighter than a photon kind of thing, how you could possibly detect one anyway. I mean, you're obviously only detecting it because somehow you have an electron that's so tippable that you can knock it over with a neutrino. There's no electron that tippable. There just isn't. So the whole theory is shit. Just such, I don't know why people jump on those bandwagons. I mean, neutrino makes no sense on so many levels. Your theory explain radioactive decay. Well, I mean, the decay of heavy elements is sort of a logical proof. I mean, you're just basically saying, look, the more crap you pile onto one of these things, the more unstable they potentially can become in terms of having, let's say, it's like you can vibrate something until it finally breaks. It's like you could vibrate this thing a billion times, or a hinge finally breaks on a door. You can swing it back and forth, swing it back, and sooner or later there's fatigue and it falls apart. You could sort of argue that that's sort of how these atoms are, that they can take so much motion and they stretch because of it. Like each time they wobble, something stretches just a little bit. So each wobble's a little wider and a little wider and a little wider. And it's a tiny, tiny amount, but that tiny amount is a real amount over time. And so you could argue that over time, they're losing little pieces of energy because they're very complex. So the pressure between their electrons, let's say they lose a photon, over a period of time. And once they lose enough of those photons, these little ones that happen once a week or something, then they start to wobble in a bigger way and more stuff flies off. So how to say that? So the decay really depends on some sort of more substantial thing than just creating some photons. It has to do with actual atoms breaking down into another kind of atom. But if you just measured, say, how much infrared radiation was coming off a radioactive isotope, that infrared radiation might not be directly related to decay. So it wouldn't require you to break two atoms apart to create some heat. So over time, I could argue that uranium is always hot and that it's always decaying by losing electron pressure, and that eventually it loses enough electron pressure from just shaking, just Browning motion, and being too bulky. And eventually it loses enough inside the nucleus and it splits. So it's like when a black girl shakes her ass. Yeah, well, that's like a very Dick Woodman kind of analogy. I mean, you could have said Spanish girl, right? Or you could, I mean, what's the difference, really? I don't know. You know, this whole you people and your racism into actual, you know, you sit there and bother making it anatomical. Ugh. You know, if you really go to Africa, you know, look at black women overall in Africa, you know, they don't have like American fat ass, you know, not exactly the same. You know, they've American, well, whatever, just not even going to it. I just, you know, whatever. I'm just so sick of people having to play these silly games. Seriously, though, yeah, I don't think you're capable of that. I heard you say galaxies are flat. Well, it's kind of obvious they are in one of your videos the other day. I don't get how you say that when there are obviously spherical ones. Where? Where's a picture of a spherical galaxy? You understand a sphere is a round ball. That is, it's equally dense all the way around. So uh, where is that? You know, where's the spherical galaxy? Could you attract an isotope? I don't know what that means. 128. What does that mean? I mean, I'm sorry, but you know, you really are kind of incapable of asking even. You know, you got a constantly spinning compass, and now you're talking. Could I attract an isotope? What do you mean? Put my hand out and go, "Come to me, radioactive isotope." What are you talking about? Let's see. So he says there's obviously spherical ones. So again, you think sphere is the same as round. Never said galaxies weren't round. You know, and they have round symmetry like a pancake, but they're not spheres like a bowling ball. And I think they're clearly flat because I think, I think they're always connected to a, they're formed by almost what we're talking about, by atoms splitting. Well, when dense matter, quasar, small galaxy, a compact galaxy, when it breaks into two and becomes a binary system. And so that's how the galaxy starts to form, is it starts as two binary things spinning around each other, and that's where the arms are coming from. I saw them in a documentary with that guy, Neil deGrasse Tyson. Well, I'm just saying, in my experience, I've seen no image of a spherical galaxy. Well, they're clearly disk, and they don't have to be spiral, but I'm just saying, I've never seen a round spherical galaxy. I've never saw a galaxy that looks like a sun. All right, so I just haven't seen any image of a sun-like galaxy, with stuff in the middle and stuff all around every side. So they're always disk in the sense that they're flat-ish. Flat. It's definitely an important function to understand how they're formed. So I'm just saying the idea, the trick is if they're binary things, two things, can't orbit each other this way and this way at the same time, right? They just can't do it. So they have to orbit each other in a plane. So it always has to be on a plane. They can't do spherical. They could move in different directions, but they'd always be flat while they did that. So the idea of a binary system automatically creates the idea of a flat system. So that's all I'm saying, is that's a reason to believe that's probably something to do with the mechanism. The solar system has the same fact. It's flat. There's only 6 degrees, and it's really all, if it wasn't for Mercury, right, which has it's pretty out of alignment, but the rest of the planets are only 3 degrees out of alignment. So that means there's only 3 degrees of fatness to the solar system, just 3 degrees off, 3 tiny little degrees without Mercury. Mercury makes it 7, but everything else is within 3 degrees. All the other planets line up within 3 degrees. So I'm just saying the solar system is incredibly flat also. Incredibly flat. And there has to be a cause for that flatness. Did you end up watching that refutation of relativity by that Chinese guy? I don't know. Was it a watchable video? I think I already saw it. The Who guy or whatever his name was. What was his name? And it's all mathematic chicanery, right? It's nothing to do with anything. There's no logical refutation. You can just pound relativity on the subject of its paradoxes. And I'll continue to argue that it's completely dependent on some sort of notion that you can't shoot photons straight. So when you shoot a photon parallel to your motion, tangential to your motion, perpendicular to your motion, you can't do it. The photon somehow always goes forward. Somehow. And somehow it goes forward and it moves at two speeds essentially. One speed that satisfies your conditions, and then another speed that satisfies an observer's conditions. So somehow it gets from point A to point B, and point B is a further point away, even though it was supposed to be perpendicular, but it wasn't. I mean, I'm just saying those are silly rules in my opinion, that I can't make a photon that leaves perpendicular. I can't ever shoot straight. So again, as I pointed out, if you ever get into the Star Wars situation, your light gun won't work, because no matter where you shoot it, it's always going to move somewhere else. Centrifugal is just an illusion. There is no centrifugal force. There's just your velocity and your acceleration in a new direction. So nothing's really, there's no centrifugal force. There's just two forces. Your velocity is a force, you've already absorbed it, and you're applying another force, which either is a tugging force, a tension force with a string, or you apply a gravitational force and you create a round motion. But there's just two forces. Your velocity in one direction that you've already gained, you already earned, you already consumed, and a new force that's constantly changing your net velocity. Well, I'm craving a dog made of corn. Thanks for the chat. We'll talk again soon. Yeah, well, we might not. I'm just saying I hate trivial people. And you're behaving trivially. A joke now and then is fine, but that seems like all you really got is a shtick. I mean, even to think that a common person would think a corn dog craving, that might, that might be a great line in Arkansas or something. Geez, the rest of the world's a little more sophisticated than that now. Hard to associate with anything called credibility. It's like saying I'm craving a bucket of cotton candy or something. It just makes you sound like an asshole. I mean, you're kind of cliche. Corn dogs, black booty. You're just, why don't you just go with like some sort of big hooter thing next? Just to complete your Homer Simpson profile. Oh, whatever. Yeah, I look like the guy from Back to the Future. Yeah, can't even remember his name. Do you hate Jews? There we go. Just another guy who's they're all lost in this crap, Black women's all got big asses, and Jews is all greedy fucks. God. Pathetic people. Okay, so I don't know where all this trash is coming, but I do enjoy blocking people, so bring it on, fellas. Let's see. Did you learn about systematic control of the Jews? Yeah, no, I didn't. Uh, and such. Synagogue of Satan. Oh, that's really interesting. All of this bullshit. I mean, for what? You're afraid of Jews. You're scared of the Jews. We'll see you later, Ozzy. Black power. Fuck you in the ass. Interesting. I mean, it must be like some sort of spam thing. All of a sudden the spammers show up. All right. It's very bizarre. I wonder if the view numbers went up or something. Just as a bunch of bots show up or whatever it is. Retard bots. Probably part of some Google conspiracy. Yeah, 25 viewers, so they're all some sort of spam thing. Wow. How cool is that? Spam comments now. Oh, whatever. Yeah, and what do you look like? You're afraid to even have an icon. Jesus. Pussy, pussy, pussy. Well, why do people? It's always just a waste of time. Why do people? Because people are ignorant, stupid, smelly, fucking maggots. That's why. Ugh. People suck. Yeah, we keep letting people breed, and ignorant people. And they obviously have these morons as kids. We ought to go rape their parents. Let's go find out who these people are and rape their parents. They obviously need a good raping. Not in a procreative way, in a completely violent way. We should rape them in just a pointless, violent way. Use them as test subjects just to do a documentary film on how bad rape is by raping them in all the worst possible ways possible, just to show people how bad rape is. We should shit in their mouth, do all that kind of shit. No, there's no excuse for somebody having a child who behaves the way these people do. You can't raise your children to be better human beings than this, then yes, you and your kids should be shot, with rape bullets. You should just, I don't know what to say. It's just so bad. You should kill your own kids. If your kids are this useless, you should go out and do the responsible thing and abort them, even if they're 25 years old. You have no business setting your little monsters loose. Yeah, my battery wore out. That little vape thing is really convenient. I did figure out if I drill a hole in it, I can refill them. So, so I can wear out the atomizer completely first. So it doesn't really, it only lasts like a day. But anyway, it is conveniently. This is just so much heavier. But they both have their advantages. Really is nice. I used to have to do the stupid wire thing, and I was, because I never made a good switch. And anyway, this is so much more convenient not to have to, and that's doing it the right way in this case is better. Well, frankly, I don't think TV didn't raise these morons. Come on. And I don't even, public schools. I'm sorry. I don't see how they're suggesting, any of this kind of behavior makes sense. They learn this at their dinner table or something. I mean, their parents are obviously monkeys. They did learn how to be a monkey from their parents. I mean, I'd say school is highly inefficient at educating, but I don't think it uneducates. I don't think it negatively educates. Yeah, well, thinking is kind of good advice. I don't think my father ever said anything that direct, but he did sort of by example. He wasn't an impulsive person, so. And you'd see him contemplating choices before he decided to do something, So, yes, clearly thinking is a good idea. Unlock me, you nigger. It's just so amazingly interesting. All right, so come on, physics people. Sorry that this got distracted by crap. But that's, such a difficult world to function in because it's hard enough to get the job done. It's like there's so much noise and bullshit, and just these extra added distractions, just gets in the way. Malicious time wasters. Homo simpleton. Yeah, that's a brilliant name. They think this stuff is like hilarious or something. They really, I'm so funny. No. There we go. We have a new video, replacing cap and rotor. Well, that's not at all interesting. That's a 2-minute job. Well, whatever, 10-minute job. Totally uninteresting, I'm sure. I mean, uninteresting in the sense that why would I want to watch, something I've only done 684 times? It's interesting. I mean, the Franklin Who guy doesn't really make videos about physics. It's kind of strange. I don't know why he doesn't have physics videos on his channel, but doesn't have too many. All right, well, looks like we've wound down here. There's no physics conversation to be had about gravity or pressure. Two kind of important concepts. Heat. So I will try again next time and such. All I can do, is give you the opportunity, but there's no one who wishes to engage me with a rational counter argument. So we'll just have to wait till that person shows up. What we'll have to do. don't have a trace. So anyway, till the next time and such. More than what now?